Okay, I hope you guys can see this okay. Hope you can hear this okay. Intro to electricity, all right? We're not going to get deep into theory, electrical theory and stuff like that, but electricity, like most cars now operate, are very dependent on electrical circuits. And we are going to have to troubleshoot electrical circuits. So we need to have a basic grasp of electricity before we can start using some of the tools that we have to troubleshoot a faulty circuit. Some quick definitions, all right? There's three components of electricity, all right? Three components of electricity. There's voltage, there's current, and there's resistance. In every circuit, there needs to be these three, or you don't have a circuit, or you have a faulty or short circuit, all right? The first thing is voltage. Voltage is electrical pressure, all right? The symbol used for voltage is V, or sometimes you'll see E, because back in the day, we're still learning electricity, it was known as electromotive force. So depending on your textbook, or if you look these things up online, you may see V or E. This is electrical pressure. This is pushing electrons through a wire or through some sort of connector throughout the circuit, all right? Current. Current is the flow of electricity. This is what's turning on the light bulb or the horn or whatever it is that we're trying to power, all right? Current is actually, it's the actual number of electrons passing through a circuit at a certain point. It's something like 6 gazillion or something like that, all right? It's 19 zeros after a 6. So it's an insanely high number. So we use current so we can manage that number a little better. The symbol for current is either known as I or A. Current, the units for current is something called an amp. So that's where the A comes from. I stands for intensity, all right? Because if you have more current in a circuit, your light will be brighter. If you have less current, less bright. And then the last thing is resistance. Resistance slows the flow of electricity. You need to have resistance in every circuit, all right? A circuit without resistance is called a short or fault circuit, and that's very, very dangerous, all right? And we'll go through some examples on that. So let's just look at a quick diagram to see how these things work with each other, all right? So if I have a battery and I'm going to a light bulb and then I'm coming back to the end of my battery, all right? The word circuit derives from the word circle. Everything in the circuit has to come back to its source, all right? So I have a battery, I have electrons coming out, I'm going into this light bulb, all right? And I'm coming back to my battery. That's my circuit, okay? And so if this is all set up correctly, this light bulb will turn on, all right? Now, if this battery has, let's say it's just a AA battery, 1.5 volts, all right? That light will have a certain brightness. Now, if I swap out this battery and I put 9 volts, what would we expect that to do to the light bulb? We would expect that light bulb to be brighter. I have more electrical pressure, therefore I'm pushing more electrons through that light bulb, and the intensity of that light bulb is going to be brighter. Think about, let's say my car broke down and I have to push my car down the road, all right? Well, I can push it and I'll get it up to a certain speed. But if we had 5 people pushing, if we had more pressure, all right, we would push that car faster. Therefore, in the case of electricity, all right, we would have more brightness. Now, resistance in this circuit, this light bulb is the resistance. It's what's called a load. This is using up these electrons, slowing them down before they get back to the battery. That's extremely important, all right? If you don't slow down the electrons, if they don't go through some type of load, all right, you're gonna have a short or a fault. And usually what happens is an electrical fire, all right? If for whatever reason, if that light bulb wasn't there, and I went ahead and I just had this right here, there is nothing slowing down these electrons that are going through this circuit, and therefore they're going to get really hot, all right? Just like when you rub your hands together, it creates heat. That's what you're doing. You're creating friction. Electrons are rubbing against each other, going through there, and they're never getting slowed down by something, all right? Whether it's a motor or a light bulb or something has to slow those things down, all right? And what we have to call this a short or a fault, all right? Obviously, this is not done on purpose. Typically, when you see a short or a fault, something going back to here, we have our light bulb, all right? And somehow these wires cross right here. Or somehow maybe this wire right here gets hot and kind of burns up a little bit and touches another wire that sends it back to the battery before it has a chance to go through some sort of type of load. That creates a fire, all right? That wire will melt and usually just kind of separate, and then you have a faulty circuit. So how are we work together? Voltage, electrical pressure. The more voltage, the more you're going to push those amps, the current through that wire, and you're going to create varying brightnesses of a light or speed of a motor or anything like that. Resistance is required in every circuit. You need to use up those electrons before they go back to the source, all right? Without that, now we get a different rated resistors, all right? Electrical motor is going to have a higher resistance than a light bulb. And so we can play with these things a little bit as we get further into this course. So voltage, current, resistance. These are the three things within a circuit that we need every single time. And we're going to learn kind of to measure these things using a voltmeter to find out where we might potentially have problems in our vehicles. All right, hopefully that made sense. If you guys have any questions, we'll talk about it in class.